Okay, so what I want to show you today is a little bit of ionic bonding. Now, I'm going to take a classic combination of sodium and chlorine and how sodium and chlorine actually bond together. And just to sort of set the parameters, let me just say that sodium is number 9 on the periodic table and chlorine is number 17. Now what that means, if you remember from electron configuration, and we'll draw this up here, is that sodium has 9 electrons. And so if we remember how they're arranged, we can tell that, all right, it's got 2 in the first shell, and it has got 2, 3, 4, 5, 6. If I got that right, that's 11, 7, 8, and it's got 1 in the outer shell. So sodium being number 11 is electron configuration is 2, then 8, then 1. Now, what we know with chlorine is number 17, so it's got 17 electrons. And so, if we draw chlorine here, we know that the first shell always has 2, because that's how the electron shells work. The second shell, so we keep filling here, has 8, and so we're just going to keep going on the third shell. 1, 2, 3, 4, 5, 6, 7. So what we actually find, and chlorine being with the atomic number 17, is 2, 8, 7. Now, because that sodium is a really reactive group 1 metal, chlorine is a really reactive halogen gas. They don't just really exist that well in the wild, if you like. They need to be balanced, and they need to be stable. And how that stability exists is when they form compounds. And so sodium, in its ideal world, wants to actually get rid of this electron. So it wants to kind of almost become like neon, which is a noble gas. So what sodium can do is it can give its electron to chlorine, and the reason chlorine wants it is because it wants 8 electrons in its outer shell, so it kind of wants to be like argon. It wants to be stable, so it will accept this electron. So effectively what sodium does is give chlorine its electron. Now that means that chlorine effectively has gained an electron, and it kind of has a new electron configuration, which is 288. Sodium has kind of got rid of its electron, so it's kind of like it's 28. So this means that if it's got a balanced charge as sodium, the actual atom itself, but when it gives away an electron, it actually loses that electron to chlorine, which means it's got 10 electrons, which actually means it's got a net charge of +1, right? So we can actually say that sodium has become positively charged. Now, in the same respect with chlorine, we know that chlorine has, and I'll just write this here, chlorine had 17 electrons, it had 17 protons in its atomic form, if you like, and then because it's accepted an electron, this has become 18 electrons, which means it's got a net charge of -1. So we can kind of represent that like here. Now, because of how the charges actually work, positive and negative are attracted to each other, that is what effectively kind of forms the bond between sodium and chlorine. And so it becomes a sodium ion and a chlorine ion, a positively charged and negatively charged. And that's a rule for life. Metals are always going to be positively charged, non-metals are always going to be negatively charged, and we can work that out from the periodic table. But essentially what happens is this really reactive metal, when you put it in water, which fizzes around and goes nuts, and this really, really poisonous toxic gas forms this wonderful compound that we know as NaCl, and there's no small numbers because it's positive and negative, they're just one atom to one atom, and it forms this NaCl, which is what we know sodium chloride, or what you know is table salt, and that's how it's made.